last week, definitely you have a midterm exam and also as well as a final exam. I'm thinking about a way to waive the final exam in case we will select the project. So pretty much if we have the group project, then you don't have to take the final exam. So by the next class on Thursday, so the next class we will have the exercise lab in the 163. Until that time, why don't you form your team by 2 or 3, because we have 11 students, you are auditing the course, so you may not be the part of the project or any class activity. The other 11 students need to form a team by 2, first 2, okay? Because we have the odd number of the students, so one student will join the one of the team. So why don't you form by 2? But I'm not going to allow the team only by the PhD student. We have the 2 PhD students, Fatima and Wesam. So need to find someone else. Otherwise, also we have the electrical engineering and computer engineering student, the topical and the other side. So you guys cannot form a team together, okay? But if you believe you can manage the project, then you guys can do that. Otherwise, why don't you form a team by 2 by the next class, okay? At that time, if you do not form a team, I'm going to assign the team, okay? Then you will have the project. Also, since we do not have enough time to discuss details of your topic, so if you form a team, so why don't you discuss about the project topic that you are going to implement using the math videos on top of the Hadoop system. Okay, at that time, you already saw the several examples of the application of the Hadoop system, but you can bring your own current research, or if you are working in the company that where you can find some opportunity. So at that time, so you can bring your current project or current work to the classroom project. Okay, that's much better. So otherwise, you can find the interesting topic. The main problem is whether you can have the data or not. Okay, even though your topic is fantastic, is wonderful, but if you cannot find the data, that's not possible project. So think about whether you can have the data. For example, I'd like to implement the Walmart shopping recommendation system. However, if you cannot have the Walmart data, even I do not have, so it's not possible. Also, I'd like to utilize the Hadoop system for the searching gene sequence, okay, or the DNA sequence. But if we do not have such data are available actually for NIST or the internet. But in case if you cannot find your data set, I don't think it's possible to implement. So first think about the realistic, the data, and then using that data, what can you implement using MapReduce, the programming on top of the Hadoop system. Okay? At the time, it can be searching, it can be analyzing, it can be various topics using the MapReduce program. The main purpose of the project is to get used the MapReduce and Hadoop system. Okay, so don't waste too much time to learn the new programming Java or to get used to your data. If you have your own data set, if you have your own problem, that's the best one. Okay. Any question? If you can generate the US synthesized data, so that's also possible. Okay. At that time, for example, I'd like to use the network log data. So network log data, it can randomly create the IP address or IP or the time and so on. At that time, we can use such data. Okay. But it should be reasonable. Yes.
Professor, you said that if you're doing the project, you need to take the exam, right? The final exam.
I'm thinking the project should be mandatory.
Yeah.
Then at the time, I'm not going to have the final exam. But all of you you guys do not form a team and do not have any interest doing the project, then I'm going to cancel the project and we will have a finance. Okay? Okay, so then Thursday, I'd like to check your project team and topic. Then you can submit the first page of the project. That will be the proposal. Okay.
Next week.
First, I'm going to wait until the Thursday. Okay. I think that you may have a better idea after today's class, after you learn what is the math reduced program. Okay. So last week we have talked about what is the big data and what is the big data system. What is the example of the solution of such a big data, which is the Hadoop system. Hadoop is the Apache Hadoop Foundation group. They developed two things. One is HDFS, Hadoop. First one is Hadoop distributed file system. So file system is a different file system to support the distributed computing. Okay? And in addition to the HDFS, there's another core component that is the map reduced programming system. Okay? That we are going to discuss today. So I'd like to quickly summarize the last week discussion. First, we have the client, okay? Then we have naming node. The naming node is what? It's a master node. Then will be act as the coordinator, okay? Will control our Hadoop system. So there's another one. Secondary naming node, but this is not a backup system. This is the housekeeping job, just to assist the naming node. So that is the reason naming node is a single node of failure. In case this one is gone, entire Hadoop system will be gone. So also we have a number of data node. So data node 1, data node 2, data node 3, data node 4, and so on. Okay? So each node has what? The HDFS. When you insert the Hadoop, you can download the Hadoop package from the Hadoop.apache.org. If you go to the website, you can download the current version of the Hadoop. And when you insert the Hadoop system, it will install what? Basically two parts. Hadoop distributed file system on top of existing file system. It can be EX1, EX2, EX3, or the FAT 13, 16, or the 32. It doesn't matter, NTFS. Okay? It will be installed on top of that. And also another one is the map reduced the system that we will discuss. First, that means we need to have the big data file on top of the HDFS. So when client request to write the file, that should be on the client side. Okay? Local file system, not Hadoop file system directly. You need to ask request to the naming node first. Then naming node should know which nodes are available. Okay? By sorting, with the sorting. The distance, we discussed about the network distance in Hadoop system. If two files are in the same node, is the distance 0. In the different node, but in the same lab, it will be considered 2, something like that. Okay? So, ordering by such a distance, then naming node will return the client which node are available. At that time, client will segment the file by block size. Block size usually 64 megabytes or the 128 megabytes, which is much larger than the traditional file system or the traditional DBMS system. Why?
Can you say again?
Why we need such a much bigger size of the block?
Because the size of the file itself is very large.
What about the traditional operating system? Operating system can keep such a big file in the file.
So maybe the performance would be faster because you have bigger blocks.
I think that it reduces the
Faster? For what? What kind of job? It's a batch job. It's not online transaction system. Okay? So our goal is to process huge amount of file data at once, as fast as possible. It's not online transaction processing. It's different from the relational database management system search engine. Okay, it's not like such a search engine, but it needs to handle such a big file. So we need such a huge amount of big block size. So for example, 64 megabyte. Then client will, for example, naming node return data node 1, data node 2, data node 3 are available. So first copy the first block directly to the data node 1, block 1. Okay? Once this, so this is only the 64 megabyte. Once data node 1 is receiving the data from the client, then forward the data to the next one. How does the data node 1 know which one is the next one? When client after client receive the available data node from the naming node, then it will ask a copy the first block to the first available data node. At the same time, provide the information about the following node, data node 2, data node 3. Then copy the block 1 also, then copy the block 1 once. Data node 1 is done to copy the file, then naming node should know where this block 1 is available. Data node 1, then data node 2, and data node 3 by ordering the distance. Then it will be something like that. The block 2 will be copied, similar pattern. So block 2, block 2, block 2. So block 2 is data node 2, 3, 4. So one of the difference between the HDFS and other file system is it keeps the 3 copies of the block. Okay? So as a default, the HDFS will keep the 3 copies of the data. Okay? Along the different data now. Why 3 copies? One reason is in case one of them is not available, the other will be available. Then the system will be available without stopping an entire system. Another reason is parallel processing, data locality. So if the data is distributed, then we can get the better performance. We will see in the MapReduce the system. Okay, then when you read the data, first client will ask naming node, which node are available for the specific block. Then after you got the first one, because it's the closest one, then access the data. At this time, this read and write in HDFS is write once and read many times. So only read only data. So if you want to modify the data, you need to download the file to the local file system, then modify, then upload the right data again. You will test, yes, entire file.
You can append data.
You can what?
Append, like add data.
Append, you can append it, but you cannot modify.
No, you can.
So there are software that mimic the random accessing or the random modify, but according to the header file system architecture, you cannot modify, you cannot access the randomly using the address, the header file. No, it's not possible. And from time to time, data node will send the heartbeat every 3 seconds. I'm available, so data node, naming node should keep the which data node are available. In case the data node 2 is not available, which means until within 10 minutes, last 10 minutes, there is no heartbeat, so it will be considered as unavailable. The node. At this time, this node may not be available. Then the next one will be used, the data node 3 and subscribe. So this is the overview of the HDFS file system. Okay, any question?
No, but
Yes.
if one of the blocks get corrupted or removed, it will be replicated by the file system. So I read about it.
Oh yeah. So you can use, for example, if the data node 1, so this node is unavailable, and using the other you can recover. Then who is in charge of that? The naming node will be in charge of such a recovery. Okay, so then last time we quickly go over this part. What is the map register? Using this is the HDFS. By the way, today is the due date of your first reading assignment regarding to the Google file system. You probably realize Google file system is almost the same as this one. After the Google developed a new file system for the big data, then they opened their architecture. Because they did everything, so there is nothing to lose. And one of the person who developed the Google file system, the coding, he established the Hadoop the foundation under Apache Foundation. It's an open source project. So that is the Hadoop distributed file system. So I believe it's not very difficult to understand. There are some different names of the concept, but actually basically it's the same thing. Okay. Then, anyway, after we build such a Hadoop file system, why we install and implement such a HDFS? We need to process such a big data, right? To do that, the traditional distributed file system, or traditional parallel system, or traditional high performance computing, HPC computing, how can you do the programming for such a parallel distributed system?
It's complicated.
You need to code differently. Okay? So for example, is there anyone who took the parallel programming? So at that time you need to understand the multi-core and multi-thread. You need to take care of such a different sometimes algorithm. Otherwise you cannot get the benefit of the parallel processing. So that's the big hurdle. That's the big problem to use the HPC, high performance computing, or cluster. So to address the problem, the map reducer is the system. Okay? Very, 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 very high level programming system. What does that mean? High level or low level? Low level means machine language. Okay? So, for example, the assembly is the lowest level of the programming. At the time, you can code actually the assembly language. Sometimes it's easy to understand that just to register and read and move copy, but it takes a long time to do that. To address that problem, there's a little bit higher level program like a C program, C++ program. what happens when you compile C program language? What is the output? Assembly language, assembly code, so instruction, series of instruction. Then your CPU, your computer can understand such assembly language. That is the reason that is called machine language. Okay. Even C languages, C++ language, or Java program, it's very hard to consider such a distributed architecture. We need more higher level of the languages, not language, using the existing language such as Java, Alpha, all of these, the head components are developed by the Java. Okay. Also, they are using TCP, IP. And so these are the coded by the Java. Each one has their own Java virtual machine. Okay. So then we need something higher level programming environment, which means we don't have to worry about what is the data node, how to distribute the job, how to collect the job. Instead, we can focus on only what? Business logic. Okay? What problem only? Without spending a lot of time for the coding part. So that is the map reducer. That is the kind of system on top of existing program language. So traditional parallel program language is you need to using the existing program language. You need to code a bunch of the parallel and distributed part. Also including computing architecture. So multi-core, multi-thread, even algorithm. But in the map reduce, that includes all of these housekeeping jobs. Okay? Just add the business logic part.
It just works in the data, how to manipulate data.
Yes.
Regardless of the codes.
So that means at least you should know what is the input and what is the output. Okay? Format plus such a business logic. That's it. That is the map reduce programming. Because of that, this is only working on the such a Hadoop file system. Okay? But new version of who is the new version of the Hadoop or the map reduce the programming, they can support non-Hadoop the HDFS, the file, but this one, so in this class we will consider such a map reduce with the HDFS. So there are two parts. One is the map and another one is reduce. As name implies, map is there is a job from the client. Also, just one more thing. This is the demo process, right? This is another demo process. Another demo process. This is another demo process. In addition to the naming node, secondary naming node, and data node for each data node, the demo process we have. You remember we have the task tracker and job tracker process. So these are the process we are ready. So map reduce system consists of two components. One is the map and another one is reduce. So when a client submits a job, what is a job? It's the
Operation.
operations. In
It's fine.
general, the job can be considered considered as a task, whatever. In operating system, it is a process. Okay? But in HDFS or MapReduce Hadoop environment, when we are saying a job means it's your project is one project. Okay? This job will be submitted to the naming node first. So for example, I'd like to count that this is one file. Okay, let's say this is a file, or we have the file, this one. And the next block, this is block 1 and block 2. So block 1 has I'm a student, and block 2 has you are a teacher. Okay? So we'd like to count the word, how many I, how many am, how many of, something like that. Okay? This is my job. So word count, this is called the tool. Typical well-known example of the MapReduce programming, just like the hello world in other program languages. So we like to count this. Our expected output is like the A2, M1, R1, and so on. Something like that. This is our expected output word count. So at that time, job means counting word from this file. Okay? To do that, first net means we like to distribute the job. Okay? This is a too heavy job to count the word. So why don't we distribute the job by what? Block. Block is already distributed along the node. So when the naming node suggests the node for each block, this naming node already consider the number of node and the distance. So you can just consider the block. So first block is available here, and the second block is available here. So you can distribute the job. You can map a job to the node. That is the map. Then count. First, from the block 1, it's a map. I don't know. Block 1 is here. I, how many I? 1. And how many N? 1. And how many O? 1. How many student? 1. This is the output of map. And from the second block, at the same time, because they are different nodes, it will be U1 and R1, O1, and teacher 1. So this is the map. Okay, map is distributed job. Yes.
Excuse me. And second node, there's 2A. So one in the first block, one in the second block. So
Because they are separate nodes, they do not know each other. Okay, this is only the map. In the mapping, they will consider only the block is assigned to that job. Okay, this is a mapping.
because we didn't consider the second node, the first block, because second node has
For example, his question is, why don't we consider this and this is the same? So will be 2 right? To do that, they need to communicate each other. It will be huge overhead in distributed system. For better performance, they do not communicate each other. Even though I understand, if we can combine earlier, they will save the research? No. Actually, they need more research to communicate each other. So they do not communicate each other. That is the mapper. Then after they complete the job of mapping, you can send such a job to the reducer. Okay? So which means, so for example, this one is assigned as the reducer pool. The naming node will assign one or more node. Okay? For reducer. Reducer is combined. So they send block one will, for example, this one is the reducer. So reducer, each data node 1 and data node 2 will send this data to reducer. And also this one to this. Then reducer will, as name implies, reduce, collect, grouping the job. For example, how many of A11? Eventually it will be considered A2. And R1 and on, I think that this one is first, R1 and so on. This is our expected output. Then this will be stored at HDFS file system. The output of this one will be stored at the HDFS file system. Then, to see the output from the client, they need to re-download the file first. Okay? So this is the very basic process of the map reduce program. Okay? So simply two cases. Mapping. Mapping is to distribute the job to the HDFS file along the blocks. Okay? So if you have the 3 blocks, how many mapper? There will be 3. So based on the data locality. Then each mapper will create the output, intermediate output. This is called the intermediate output. It's not final output, it's an intermediate output. Intermediate output will send to the reducer. Sometimes it's one, sometimes many reducer, depending on your job. In this case, 1. If you do not specify, it's 1. However, sometimes I'd like to receive A to R. First reducer, S through Z is the second reducer. Then A through, in this case, this one will be this, and student, teacher, and you will be the second reducer. Okay? Then the output will be, each reducer will create their own the output file on HDFS. So this time there will be 2 output files. You need to combine after you download the client to see entire output. You will see details. This is just the high-level overview of the map reduce program. Yes.
In this case, we have just 2 wall blocks. If we have 3 wall blocks, so we have like 3 intermediate blocks.
So for example, if this file is a 5 block, there will be 5 blocks, okay?
Yes.
Along the node, then there will be 5 mapper, okay? Process.
Okay. Another question is, if there, we cannot say we cannot make the calculation in the first blocks because it's like intermediate
Yes.
calculations because the overhead. So that third one, the last one, they have like
Yeah, reducer will take care of.
there's no overhead there. With the
Actually, that's a good question. Reducer sometimes can be bottleneck of such a data. However, after we reduce how many different words comparing the number of words, actually number of words, the distinct word is quite reduced already. Okay? So at that time you can separate, you can create the more reducer. Okay?
So let's say that you have each one will be assigned two outputs or two outputs.
One output for each reducer.
Okay, then these three reducer needs to be reduced to another that node
No.
to collect the.
The output of the reducer will stored at the HDFS.
Right.
Yes. Then to see the output, you need to download all the output file, the local file. Then sometimes you need to merge the three files.
So I need tools actually.
There might be tools, but you can just open three different files. Okay. Okay. This is the map reducer. So before we discuss about the details of the map reducer programming, so we will see what is the feature of the map reducer. So automatic parallel and distribution. Is there any the process or the step to specify the how many mapper, how many register? No, actually,
Depends
the
on the
job.
job. Depends on the job.
Depending on the job, but mostly you don't have to worry about it. Map reducer program will take care of the automatically parallelize based on what? HDFS, already distributed. Okay? And also first tolerance, for example, if the block 1 is not available, it will use different node where the same block is located. Also, another benefit of using the map reducer is sometimes you don't know what happened. This node is very, very slow. At that time, naming node realize from time to time check the performance. If this node is slow to count the word, then start another node, this one. Okay? Then compete each other. If one of them is the finish, complete the job first, earlier, this one will be considered as the output. Then discard another one. That is the speculation. So Hadoop supports such a data programming speculation. We will see details of it. Okay, yes.
Like an actual coding these, like for a client, just I need to.
We will see later.
So about the third block, they had already copy from the first block.
There is no first block yet.
DN3. Not number 3. Number
This
3,
one?
yeah.
Yes.
They had already block number 1 and block number 2, isn't it?
This one has a block number 1, block number 2. Yes, this one has the block number 1 and block number
We
2.
don't consider like who's
This
the memory?
one, any
About the
node,
memory. We don't consider.
any node knows everything about the even the performance, how fast the current job is.
What is the distance?
No, first time when naming node assign the job, they will consider just the network distance. Okay, then from time to time check the how much they give. Okay, if that is slow compared to other node, they move the job to another node. For example, sometimes this node and this node is the working node. Okay, as a mapper. And data node 4 is available, but there's no block 1 at the time copy the block. There's the new one. Okay, actually the copying the 64 megabyte doesn't take a time. So yes.
It also considers fault tolerance. So like the Google file system, it could place blocks in different files. So
Yeah.
for recovery.
So that's the based on the number of copies. So this is a big picture of the map reduce. That's I already explained. So mapper, there's a mapper, so they from the data source. So in this case, it's a block 1 and block 2, and always that can be the benefit or the disadvantage of the map reduce programming. Map reduce programming system can consider only key and value format. What about the relation? Compared to the relational database model, you can see very, very simple. What about the relational model? It has a primary key, also it has a candidate key, and it has the bunch of attributes. However, here, map reduce programming, it has only the key and value. even key is not the primary key. You can have the same key. Later you will consider combining and compare. So only key and value format. For example, in this case, I is the key, 1 is the value. Okay, and here A is the key and 1, 1 is the value as the array. Eventually you will combine. And also, sometimes if you have, actually I didn't explain, the first, sometimes the map reducer consider entire line as the value and offset. You know the offset. What is the offset? Offset is the offset is the distance or the number of bytes from the beginning of the file. Okay, so for example, this one is definitely 0, and you can count to the byte. Then this is the 121. There is the UV, whatever. So, and also new line character. If you have the new line character like the \n, okay. So this one is the entire I and H student is the value, and 0 is the key. Next line, 121 is the key, and entire UV whatever is the value. So you need to, if you are focusing on specific information in the raw file or whatever, you need to manipulate. That is the job of map programming. We will see details later. So that's the reason is a key value. Key, always key value. So somebody said map reduced programming is the kind of the finding, it's a game to find key value form. Whether you can find key value pair, key value pair, always key value pair. Okay? In the relational database model, you need to consider primary key, you need to consider attribute. Also, you need to think about the data type. You need to also sometimes think about the constraint, foreign key, reference key, bunch of the condition. Here is a key value format only. Okay? Then, after we distribute the job in mapping, we need to find key value, key value, key value. Then, before actually we send the data to the reducer, okay? By the way, what is the mapper? And what is the reducer? It's the process, remote process running on data. It's the called task tracker and job tracker. Okay? The name is the task tracker and job tracker. We will see more later. So mapper will receive the intermediate value. And another, if you have another reducer, how can you differentiate the reducer? For example, sometimes I'm going to receive the key value A to E. This one is C to S, key to V, something like that. Okay? Otherwise, if you do not specify that, only one reducer will be created and running for your job. So final key value, this is one file on HDFS. This is another file on HDFS. Another file for HDFS. In this case, 3 different files. To see entire job output, you need to download 3 files, 2 local files. Even though you do not know yet how to download the file yet, so we will see on Thursday the command, specific command. Then combine. Yes?
So the number of reducers depend on the number of the keys.
No.
Right?
No. So default is 1 reducer. But if you believe you need more reducer, when you run, submit the job, you can specify number of reducer. Okay. Also, we will learn how to differentiate the range of the reducer. Okay, we will learn later. So this is the map reduce. So the first one is the job tracker. Actually the mistake. there is a job tracker and task tracker. So job tracker is the kind of coordinate of the job. Okay, running on, it can be running on naming node, but if the naming node is too heavy to keep entire meta information, it can be separate the node. So you can specify when you configure your map, the Hadoop system. Okay. So usually job tracker running on the master node, not always. It can be separate. So you can configure your Hadoop system. Okay. And this is the job tracker. And job tracker is the process, remote process to control entire your job. This job. Then who is in charge of the mapper and reducer? Task tracker. So that's the reason first time I asked you what is the definition of job. So job in Hadoop system, in general job and can be considered as a task, but in the Hadoop system, job is your project and task is your mapping or reducing, mapper or reducer the process. So how many tasks? One job has many tasks. Okay? Even sometimes it has a task attempt. Task attempt means I need to, sometimes it can be failed. Some part of the task. Then try another attempt. Okay? Also, always each mapper should run on one block. The node where the register is, that is called the data locality. Okay. If you have the very low performance of your system, but you do not have the data in another node which is available, you need to copy the block. Okay, then keep the data locality. That's the another reason why the map reducer is so fast. So how can we create the job while running the job? You need to create, there are three. Mapper program with one job. And another one is reducer program. Also, there's another one, is the driver program. Driver is coordinating this mapper and reducer. So Java what? It's also Java. So at least the three.
The driver is the job tracker.
No. Driver can be part of the mapper and reducer, but we try to make a template to simplify the programming. So we separate the driver, mapper, and reducer. You will see each of them, okay, later. Then after you code these three and compile, you will have what? Class file. Right? If you know any object-oriented programming, it will create a class file. So you can combine, okay, with one jar file. What is a jar file? It's an archive file. So like the tar file in Unix system or Linux system is a jar file. So after you compile the entire file, make the jar file. So you have the foo.jar file, then submit this one using Hadoop command. At that time, you need to specify input directory and output directory. Okay? The input directory means not local directory. Directory where your input file is located in HDFS. Output directory is where you want to store the output file. Okay? So you need to specify these two options. This is the basic. Always test on Thursday. Okay. Then we have a bunch of things today to cover. Any questions so far? Okay. We already sorted this one. So, actually, MapReduce. This is the current version, MapReduce version 1. And there is the new. There were actually there is a 2012, 2013. And there's a new version that's called the MapReduce version 2, or sometimes it's called the Yarn version. It's yet another resource